Hi dear students, once again welcome back to our channel. In this video we are starting a new lesson, that is chapter 9 applications of trigonometry. Okay, in chapter 8 we have discussed that introduction part of trigonometry, and there we discuss about how that sides of a right triangle can be expressed, that is in 6 different ways you can write that the relation between the sides of a right triangle. Okay, and we introduced that 6 ratios, namely sin theta, cos theta, tan theta. Sin theta, cos theta, tan theta, these are the 3 basic ratios. Okay, ratio means in 3 different ways you can relate the sides of a right triangle, and taking the reciprocal we will have 3 more. That means altogether we have 6 trigonometric ratios, 6 T ratios. Okay. That means we need a right triangle. Okay, if we have a right triangle, you can take the ratio between the sides of a right triangle in 6 different ways, and these 6 different ways are said to be 6 trigonometric ratios. Okay, with respect to any one of this acute angle, either with the C or with respect to A, you can take these 6 trigonometric ratios. That means opposite side and hypotenuse. Okay, adjacent side with the hypotenuse, opposite side with adjacent side, and by taking the reciprocal you will have easily 6 trigonometric ratios. Okay, and also we have discussed about some specific values. That means for 0 degree, what are the values of this trigonometric ratio? Sin 0. Okay, for 30 degree and 45 degree, 60 degree and 90 degree. And this lesson we are using these 3 values for this 6 trigonometric ratios. That means 30 degree, 45 degree and 60 degree. Okay, and in the lesson the name says some application, but trigonometry has a vast application in our day-to-day life. Okay, and how this is going to be useful for us, that is what we are going to discuss about. Okay, that means in the area of astronomy and in geography and in navigation, and to calculate the distance from the earth to planets or the stars. Okay, these are the areas we are using this trigonometry. Okay, and we will be discussing a very few of these applications. Okay, and before that we need some more ideas we should have, then only that is going to be easy for us. Okay, and for that children, suppose I am watching a building from a point on the ground. I am standing at this point and here is the building. Okay, and I want to look into the topmost part of the building. Top of the building. Okay, and for that, if I am simply standing like this, okay, in order to see the top, I have to raise my head, isn't it? Okay, and the distance of this point, okay, to this topmost portion of the building, and this line, there is a line, an imaginary line is formed there, children, and this is what we call line of sight. Line of sight. And since this ground make always a straight line, and the building and the ground, that angle is always 90 degree. That means we have a right triangle now. That means you can apply trigonometric ratios. Okay, so in order to get this height of the building, so suppose this is the building. Okay, in order to get this height of the building, if you know this angle or the distance, and also the distance from the foot of the building at that point where I am standing, you can easily calculate, you will be getting this height of the building. And this angle, this acute angle is what we call the angle of elevation. Elevation, that means the angle between this ground level and the line of sight. Understood? See, instead of I am standing here and I want to look that object, that the topmost part of the building, I have to raise my head. In the second case, see, suppose I am here at the topmost part or in the balcony of my house, and I want to see a car which is parking at the ground. That means in order to see that object, I want to lower my head, isn't it? Okay, and there is a line which is always parallel to the ground level, isn't it children? Ground level. and suppose I am simply standing here, okay, my eye is parallel to the ground, isn't it? And this line is what we call horizontal level. Okay, and from this point I want to see this object, okay, that is on the ground, okay, and this is what we call the line of sight. Here the angle between this horizontal, that means that the line which is parallel to the ground, and this line of sight, here this is the line of sight, this angle is what we call angle of depression. Okay, if you know this angle, okay, and this distance, you can easily calculate this height of the building. So children, if you have a correct idea about this angle of elevation and angle of depression, you can easily solve exercise problems from this lesson. And we have only one exercise, and definitely we can expect one question for the board examination. Okay, and the next board exam, that is for term 2, is a descriptive type, and you will have 4 sections: section A, section B. Section A carries 1 mark, section B 2 marks, section C 3 mark, and section D 5 mark question. Some cases we may getting one single question for 5 mark or 3 plus 2, that combination. Anyhow, 5 mark is the total weightage from this lesson. Okay, you can easily get it by thorough practice, and you have to definitely do some extra problems. Some cases we are not getting the exact question from the textbook, but if you have a correct idea about these problems which comes under the exercise, whatever the problems is asking for the examination, you can easily solve, but provided you have to perform very well with the calculation area. Okay, let us start with the exercise work. Exercise 9.1, first question. A circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. Okay, here is the pole in which that rope is tightly stretched with the top of the at the top of the pole to the ground level, and the angle between the rope and the ground level is 30 degrees, and we have to find out that height of the pole. This is the pole, that is AB denotes the pole, okay, and this AC is the rope, okay, and this length of the rope is given as 20 meter, and we should get this height of the pole. That is what is the question says. And also here that angle between this rope with the ground level is given as 30 degrees. See children, in this type of question, see, we know that we have to express this question, this situation with any one of the trigonometric ratios. Okay, and how can we select that ratio? We have 6 trigonometric ratios. Okay, and for that children, this is very, very important. You see that what we need the height. So with respect to this acute angle, this is a right triangle obviously, because this is 90 degrees, that is given in the figure. This makes that the pole and the ground level, okay, make a 90 degrees. Okay, so this is acute angle, this is also acute angle, and here that angle between this rope and the ground level, so this is the reference angle, that is 30 degrees. So with respect to this reference angle, we need this is the height of the pole. So we should have this side in that ratio. Okay, so that means with respect to this is its opposite side. Okay, and if you are taking its adjacent side, we don't know this opposite side as well as the adjacent side. So we can't take in this way, that is opposite side with adjacent side or adjacent side with opposite side. That ratio we can't take, that is tan theta or cot theta we can't take. Okay, why? Because there will be 2 unknowns comes. Okay, if you are writing tan 30 degrees, you have to write AB by BC, and in the next step you can substitute only for tan 30 as 1 by root 3. Okay, for the numerator AB is unknown, BC also unknown. In that case, we have to select a ratio which includes this hypotenuse. With respect to this angle B, this is its hypotenuse. AC is the hypotenuse, because this is a known quantity. 20 meter is the length of the rope that is given. And in that case, there will be only one unknown, that will be the height of the pole. Understood? So that means you have to take either opposite side with the hypotenuse, that is sine 30, or hypotenuse with the opposite or cosec 30, that doesn't matter. So I am taking here sine 30. Okay, so sine of 30 degree with respect to this, consider this right triangle ABC. Okay, this 30 degree is the angle, so sine acute angle is given as 30 degree. So I am taking opposite with the hypotenuse, so that ratio is sine. So sine 30 equal to AB by AC, that is with respect to 90 degree, this is this opposite hypotenuse. Okay, that is opposite with the hypotenuse sine 30. So sine 30 is value. What is the value of sine 30? That first row 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. Okay, so that means sine 30 is 1 by 2. So 1 by 2 equal to AB is the required height of the pole and AC is given as 20, right? So 20 will become to this numerator. So 20 by 2, this 2 cross multiplication. Okay, and this is equal to AB, and 2 in 20, that is 10 meter. That is the length of the pole. AB is 10 meter. Very simple. Next is the second question. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degree. The distance between the foot of the tree to the point where the top touches the ground is 8 meter. Find the height of the tree. Figure is not given, children. We have to draw the figure according to the given questions. Very, very important question also. Okay, here we have a tree which is standing on the ground. Okay, and due to storm, suppose from this portion of the tree it breaks, and this portion touches the ground, the topmost, this topmost part, that is the meaning of the broken part bends so that the top of the tree touches the ground. Okay, so making an angle, so this portion is now on the ground, making an angle 30 degree. Okay, making an angle 30 degree with it. Okay, the distance between the foot of the tree to the point where the top touches the ground. This is the foot of the tree, and this is the place where the topmost part of the tree touches the ground. Okay, so this distance is given as 8 meter from the foot of the tree. The point where the topmost part touches the ground is 8 meter. Find the height of the tree, the total height of the tree. Question is clear, children? Okay, so I am going to mark this points. This is A, this is B, this is C and D. The point, the topmost part of the tree touches the ground, that point is D. Okay, see from the figure, AC is the height of the tree, right, children? See, this is A. So AC is the height of the tree, height of the tree. And from the figure, and that is equal to AB plus BC, isn't it? So we should get what is AB and what is BC. And if you add AB plus BC, that will give you AC, that is the required height of the tree. And from the figure and after this explaining this question, it is clear that this part that is AB is equal to BC. Understood? This part is there on the ground. Okay, bends and touch, the topmost part touches the ground. Okay, so BC, AB equal to, from the according to the question, AB equal to BD. Okay, so instead of AB, because here AB is not making any part or any side of the right triangle, but BD is the part of the right triangle, and that is the hypotenuse. Okay, we can apply the trigonometry only for the right triangle only. Okay, that is why here you have to write this one, that is according to the question, AB equal to BD, and BD is the part of or the side of a right triangle. Okay, so in order to get the height of the building, that is the height of the tree, AC equal to, instead of AB, BD plus BC. That point is clear, children? Okay. See, children, here BD is hypotenuse, BC is this portion. Okay, and here if you consider triangle BCD, you will be getting this BD as well as BC. Okay, so here it make a 90 degree, so right triangle. So initially you can't take Pythagoras theorem, children, because here we know this one, okay, and this BC is not given. Okay, so here we have to apply first any one of the trigonometric ratio. Okay, and for that what we have to do, children, here with respect to this only this one is given, we need this one, that is BC, and for that you have to take the ratio which includes BC as well as DC, otherwise you will have two unknowns. If you are taking with respect to this opposite side with the hypotenuse, just like the first question sine 30, here opposite is unknown, this hypotenuse is also unknown, so we can't take. Okay, so here we have to take opposite with the adjacent or adjacent with the opposite, tan or cot is okay for this question. So I am taking according to this question tan 30 degree equal to BC by DC. Okay, and tan 30 value we know, that is 1 by root 3 equal to BC. BC is what we need, that is unknown, divided by DC, the distance is given, that is 8, or by cross multiplication 8 will go to numerator, 8 by root 3 equal to BC. That means we got one portion of this AC, that is the height, that is this distance we got, that is 8 by root 3. But what we need BD also, then only we will be getting the total height of the tree. Okay, so either you can apply Pythagoras theorem, or now we can take sine, because opposite side is known now, opposite side by hypotenuse, or you can apply Pythagoras theorem, that doesn't matter, that is square of the hypotenuse is equal to sum of the squares of other two sides. So here I am going to again applying that one of the trigonometric ratios, that is sine, okay, sine of 30 degree. For both ratio that acute angle is 30 degree. So sine 30 equal to BC, that is 8 by root 3 divided by opposite side by its hypotenuse. Okay, hypotenuse what we need, that is BD should come in that, then only we will be getting its value. Okay, and what is sine 30? 1 by 2. See, children, learn the trigonometry, that values of some specific angles, okay, that we have discussed in the previous lesson. Okay, that is 1 by 2 is sine 30, and 8 by root 3. Okay, and this BD will go to numerator. Okay, BD into sine 30 equal to 8 by root 3. Okay, so BD. And BD equal to, because we need BD equal to, this 2 will go to numerator, so 8 into 2, that is 16 by root 3. This root 3 is there. That step is clear, children. Here 1 by 2 is sine 30, and here in the next step BD into sine 30 equal to 8 by root 3. Okay, so BD by 2 equal to 8 by root 3. So BD equal to 8 2s are 16 by root 3. Okay, and in order to get the height of the tree, AC equal to BD is 16 by root 3 plus BC is 8 by root 3. Understood? Here that denominators are same, which means you can add that numerators like fractions in that idea, that is root 3 and 16 plus 8 is 24. 24 by root 3. But root 3 is an irrational number, so we have to rationalize. Okay, and after rationalization, so 24 by root 3 into root 3 by root 3. If only one factor come, one term is there in the denominator or in the rationalization factor, okay, so you have to just multiply and divide with that same number, that is root 3 only. Okay, so root 3 by root 3. Okay, so root 3 become simply a natural number 3. Okay, so 24 root 3 divided by root 3 into root 3, 3. So 3 in 24, 8. So the height of the tree is equal to 8 root 3. That means AC equal to BD plus BC. That is the height of the tree equal to 8 root 3 meter. This is very, very important. You should know how to draw the figure and this step. Okay, so that you can easily get into the answer. Okay, it's very, very important question. Now the third question. A contractor plans to install 2 slides for the children to play in a park. For children below age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter and is inclined at an angle of 30 degree to the ground. That point is clear, children? And for the big elder children, she wants to have a steep slide at a height of 3 meter inclined at an angle of 60 degree to the ground. What should be the length of the slide in each case? That is a question. So suppose this is the ground where that slide is going to install on this beam, and the height is, and for the smaller children, okay, this slide is kept at a height of 1.5 meter length height, and it make an angle of 60 degree with the ground. This is the slide make 30 degree with the ground. This is the ground level. Okay, ground level. And for the elder ones, okay, she prefers a steep slide, okay, at a height of 3 meter. Okay, so this is the height where that is 2 slides is going to install, and it has 3 meter for the elder ones, and that slide makes 60 degree with the ground. So what is asked? What is the length of the slide in each case? So this is a slide for the elder ones. And here if you consider, that means it makes a 90 degree. Okay, you can treat this as 2 different right triangles ABC and ABD. Okay, so in order to get the length of the slide for this case, that is elder ones, okay, you consider this right triangle ABC, and since we need this, and this is given, that is the height AB is given, okay, that is given 3 meter and the angle is given. So with respect to this acute angle 60 degree, okay, this is opposite side and this is what we need. So here also you have to take sine 60 degree or cosec 60, both are okay. And in order to get this case, that is the length of the slide for the smaller ones, okay, age below 5 years, this is the slide, okay, and if you mark this point as E, you have to consider right triangle EDB, and ED is the slide, length of the slide, and for that here opposite side, that is 1.5, that height is given 1.5 and this angle is given, we need this. So opposite side with hypotenuse, both case you can take sine 30. Here is sine 30, since here the angle is 60 degree, sine 60 degree. Idea is clear, children? So separately we can consider 2 right triangles and you can easily reach into that required length of the slide. Okay, so one by one we can solve. So in order to get the length of the slide for the elder one, I am going to consider right triangle ABC, this triangle. Okay, so here we need AC. So with respect to this acute angle, opposite side with the hypotenuse. Okay, so sine 60, you have to decide which is the ratio can be selected. Okay, that idea is clear, children? Okay, here it is sine. Okay, and that means in that ratio this side should be there, AC should be there either in the numerator or in the denominator. Okay, so sine 60 equal to, that is AB divided by AC, and its value is root 3 by 2 sine 60, and AB is given as the height of that building, that is that wall, okay, where that slide is installed. plans to install, and that is 3 meter height, and AC is the length of the slide, that is AC. So the next is you can cross multiply, that is AC into root 3 and 2 into 3 6. So AC into root 3 equal to 6, cross multiplication, okay, and AC equal to 6 by root 3. Here since the denominator is an irrational, you can rationalize, okay, by multiplying with 3, root 3 into root 3, or if you can write the 6 as 2 into 3 and 3 equal to root 3 into root 3. Anyway, you will be getting that answer. Here anyhow I am going to rationalize by multiplying and dividing with the root 3. Okay, so 6 root 3 divided by root 3 into root 3 is 3, and 3 in 6 2. So 2 root 3 is the length of the slide for the elder ones, because I considered this right triangle ABC. Okay, and in order to get the length of the slide for the smaller ones, I have to consider right triangle EBD. Okay, so in triangle EBD, okay, which ratio children? Here this is a reference angle, so opposite, that is 1.5, that height is given, and we should get this one, that ratio should include that side, that is ED. Okay, so that is opposite side with the hypotenuse. This is a 90 degree, so this is hypotenuse side opposite to 90 degree. So sine 30 degree. Okay, here it is 60 degree, here that angle is 30 degree. So sine 30 degree equal to EB divided by ED, and sine 30 value is 1 by 2 equal to 1.5, that is the height, and ED is the required height, length of the slide. So ED equal to 2 into 1.5, that is 2 into 1.5 is 3 meter. This is the length of the slide for the smaller ones, and this is the length of the slide for the elder ones. Now the fourth question, the angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Find the height of the tower. As usual, figure is not given, children, so you have to draw the figure, and for drawing the figure you have mark. This term 2 is a descriptive type, so each step you will be getting mark. Okay, so don't miss any one of the steps, children. So draw the figure first. So here we have a tower, okay, and a point from the foot of the tower, and which is the distance. See, what is the distance? 30 meter away from the foot of the tower. So this is tower. Okay, this is on the ground, and from this point, which is 30 meter away from the foot of the tower, and angle of elevation that is given, children. So the angle of elevation, okay, of the top of the tower. So from this point to the top of the tower, that is what is angle of elevation, I already explained, and that is given as 30 degree. And what is asked? What is the height of the building? That is, if I am marking this as ABC, and the building makes always a 90 degree with the ground. So this is a right triangle ABC, so that you can apply trigonometric ratios here. Okay, so which ratio you can take? Here, see, children, this is acute angle with respect to this, that height of the building, that is the tower, should include, that is opposite side with its adjacent side. With respect to this is the adjacent, that is the only known quantities given, children. So you can't take this its hypotenuse, because that ratio should include this adjacent side with respect to this reference angle 30 degree. So, and this is given, that is AB. So its opposite side and its adjacent side, and that is tan 30. Okay, so in triangle ABC, tan 30 degree equal to opposite side AB divided by BC. The value of tan 30 is 1 by root 3. AB is the required height of the tower divided by the distance BC is 30 from the foot of the tower. Okay, and you can cross multiply. So 30 divided by root 3 equal to AB, the height of the tower. Okay, either by rationalizing, or you can write this 30 as 3 into 10 and root 3 into root 3. Both ways okay. So 30 root 3 divided by root 3 into root 3. Okay, so this is equal to AB. Okay, so root 3 into root 3 make 3. Okay, so 3 in 30, 10. Okay, so AB equal to 10 root 3 meter. That it is clear, children. I just rationalized by multiplying with root 3 and dividing with root 3. So root 3 into root 3 become 3 in the denominator, and that 3 will get cancelled with 30 in 10 times. So 10 root 3 is the height of the building in this case. So children, this is all about this video. The remaining problems we will solve in the coming video. So thank you children. Thank you for watching and supporting my channel. Thank you all.